Thank you very much. I am Fusini Abdulazak, popularly known as Ninja Man, a mathematics teacher. Now let's look at techniques of integration. Some integrants have different characteristics and they are approached based on those characteristics. Let's look at some of them. For example, if you have integration in a form integral du all over square root of a squared minus u squared. How do you approach this type of integration? So integration with this characteristics has a way to approach it, and we call it integration by substitution. Integration by substitution. So you make an appropriate substitution, looking at the nature of the function to be integrated, that's the integrand. So for this, if you have this, the appropriate is a squared minus u squared. So let u to be equal to a sine theta. You see that? So whatever you see, you will put there a sine theta because u is squared. So always when you have the integrand and you have under the square root a squared u squared, your substitution should be a sine theta, because you see that when you draw your right triangle, this one, when you make a the subject, you get sine theta to be equal to u over a, and sine is opposite over hypotenuse. So you see that here you get a squared minus u squared, because if you apply Pythagoras theorem to this right triangle, so that a squared minus u squared, which is here, square root of that. So that is very good. That is the appropriate substitution that you should do. Now, so we say let u to be equal to a sine theta. Having indicated clearly to you that u should be equal to a sine theta, then we have to change to u, because wherever we see u, we put there a sine theta, so that then the u should be out. For example, if you have integral x squared dx, if you change x squared, then the dx needs to be changed. Therefore, the u needs to be changed. So you differentiate this. Let this one be my equation 1. You differentiate u is equal to a sine theta implicitly. Implicit differentiation, differentiate both sides. So the u will become, because if you differentiate u, you get 1. And to be 1 du. 1 du is the same as du. Is equal to a cos theta. If you differentiate sin theta, you get cos theta. Now, substitute a sin theta into the integrand. We shall have integral du, which is a cos theta over square root of a squared minus a sin theta. All square, because a sin theta is for u. So whatever you see, you put the a sin theta squared. Now this one will give me integral a cos theta over a squared, square root of that. A squared minus a squared sin squared theta. Because does not affect a and affect sine. So to a squared sin squared theta. This will give me integral a cos theta over square root of, in fact, it should be cos theta. When I differentiated this, du, cos du is equal to a cos theta should be d theta. Here should be d theta. So d theta. Make sure you don't forget. Now, I can factorize a square out. Should be a squared into bracket 1 minus sine squared theta. This one, a squared, this one is square root of a squared times square root of 1 minus sine squared theta. And square root of a squared give a. So this one will give me integral a cos theta over a multiplying square root of 1 minus sine squared theta. This one, the theta is out. the theta. Now, the a will take off the a, so that we shall have integral cos theta over cos theta d theta over square root of 1 minus sine square theta. And 1 minus sine square theta is the same as cos square theta. So I'll get integral cos theta d theta over square root of cos square theta. This square root of cos square theta, just as when you have square root of a square will give you a. Square root of cos square will give you cos. So to give you integral cos theta over cos theta. This one d theta. Now, cos theta will cancel cos theta, so we shall have integral d theta. If you have integral d theta, it's the same as integral dx. D theta means 1 d theta. Just like you have x, 1x, and you write x. So if you integrate this one to give us theta plus c, this will be the integration, but we can get our theta from equation 1. Here we have u is equal to a sine theta. So that you divide both sides by a, you get sine theta is equal to u over a. If you want theta, you multiply through by sine inverse from both sides. So we get sine inverse of theta is equal to sine inverse. Because I want theta, because sine theta is equal to u over a. So if you want theta, you press sine inverse. Theta is equal to sine inverse of u over a. So that this integration, if you have integration of this sort, plus c, oh no, I'll put there theta. So theta is, when I integrated integral dt, I get theta plus c. So, and this is theta, which implies integral du over square root of a squared minus u squared is equal to theta plus c, which is sine inverse of u over a plus c, where c is an arbitrary constant. C is an arbitrary constant. So any integration of this form, this is the procedure to get your answer. Integral du all over square root of a square minus u square is equal to sine inverse of u over a plus c. Plus c. That is the integration of this. So integration of this nature, this is how you go. I will give an example on that. But let me go to different technique of integration. Another technique, 1. Another technique, 2. What about if you have integral du over 1 plus u squared? Integral du over 1 plus u squared. How do you integrate this? Integration of this nature. That is very simple. Let's see. Let u is equal to tan theta. Why do we say u is equal to tan theta? Because always 1 over u, 1 over something squared, 1 over something, 1 plus something squared, 1 over 1 plus something squared is tan. For example, if you have y is equal to tan inverse of x, you can get tan y is equal to x. So that when you draw this, you can deduce this one from it. Or you can have y is equal to cos inverse of anything and deduce this one from it. Watch the previous videos that I have made. You will get to understand this one better. So y is equal to u is equal to tan theta. So whenever you see u, you put there tan theta. Because I'm saying u should equal to tan theta, in fact, we should change the u. By changing the u, if you differentiate this one implicitly, you differentiate the u at this side and then tan theta, both sides, you will get du, because the u will be expressed in terms of the theta. The u will be expressed in terms of the theta. So that let's make this one my equation 1. So that if you differentiate both sides, you get the u is equal to, if you differentiate tan theta, you get sec square theta. If you have watched the previous video, you understand this. You get sec square theta. In fact, the theta, you could see clearly that the theta, the u has been expressed in terms of sec square theta, the theta. So whenever you see the u, you put there sec square theta, the theta. So the u is at the top here. Very simple. So here will be integral sec square theta, the theta, all over 1 plus u, what is tan square theta. Now, that is what I'm saying, that to do integration by substitution, you should always arm yourself with trigonometric ratios. That's very important. No two ways about that. Now, this one will give integral sec square theta, the theta, all over 1 plus tan square theta is an identity. 1 plus tan square theta is equal to sec square theta. Just like cos square theta plus sin square theta is equal to 1. 1 plus tan square theta is equal to sec square theta. So this will give me sec square theta. So that this one will cancel this, and we shall have integral the theta. If you have integral the theta, this one will give you theta plus c. Because there's 1 the theta, that's why integral the theta. And what is our theta? You're going to look for our theta from this. If you have u is equal to tan theta, u is equal to tan theta, it implies tan theta, it implies theta is equal to tan inverse of u. So that integral du, integral theta, which is theta plus c, theta is tan inverse of u. So clearly, if you have integral du all over 1 plus u squared, it is equal to theta plus c, which is tan inverse of u plus c. That's as simple as that. This is second technique of integration in this form. But you see, I'll pick the integration one after the other. Then, in fact, tell you how and when to use these techniques. Another technique, 3, is when you have integral du over a squared plus du over a squared plus u squared. If you have this integral, how do you go by it? Now, this one to look at it, it has special characteristics. There's no square root, It is like this type. But this one, you see, this one is 1 here is 1. Because this one is the same as 1 squared plus u squared. What about here? It is squared, but not 1. Here to square, it is not 1. So that technique is also different. And that's what you have to have a look at. Now let's have a look at that one. Quickly. This one, I can write this one as integral du over, I'll factorize a squared out. I'll get 1 plus u squared over a squared. So when you multiply this, you get a squared. When you multiply a squared by u squared over a squared, the a squared will cancel the a squared. You still have u squared. So I've not changed anything. Now, this one I can write the same thing as integral. Okay. So I can factorize the a squared out. Because it's 1 over a squared, 1 over a squared integral du over, in fact, 1 plus u over a all squared. Because u over a, u squared over a squared can be written as u over a all squared. That is indices. The squared affect the u, it affects the a. Now, this can be written as 1 over a squared integral. Look at the top. I can write a d u over a over 1 plus u over a squared. Look at the reason why I've written, look at the top. I've written a d u over a. So that this a is multiplying u over a. So that this a can cancel a and you have du at the top. So I've intelligently expressed this one in terms of this. Look at it carefully. Because this one is similar to this integration. Only that here is 1, but here is a squared. It's not 1. Here can be written as 1 squared. 1 squared, u squared. Here is a squared, u squared. It means that this a is a number other than 1. But it can be expressed to have similar identity to this one. So look at this. That is why I've written AB. This one cancel this one. You get du, which is at the top. So this one is not different from this. This is not different from this. And now I can write this a can cancel one of this a. So that we shall have 1 over a integral d u over a over 1 plus u over a squared. Now let's u over a to be equal to t. If u over a is equal to t, what will I have? I will have 1 over a integral u over a is t. So I will get u over a is t. I will get dt over 1 plus u over a is t. So I'll get t squared. You see that inside one, the inside is similar to du over 1 plus u squared. This is dt over 1 plus t squared. So if you have this, just as this one du over 1 plus u squared, we had tan inverse of u plus c. So dt over 1 plus t squared means that we shall have tan inverse of t plus c. But only that 1 over a will multiply that. Because du over 1 plus u squared gave tan inverse of u plus c. So dt over 1 plus t squared will give tan inverse of t plus c. In which 1 over a will multiply that. So we have 1 over a tan inverse of t plus c. So this is the technique for integrating an integrand or evaluating an integrand of this nature. So it's a technique. Whenever it is given to you, you look at it. If it's substitution, what technique must I use? Does it look similar to this or to this or to this? Insofar as it is not double integral, it is not triple integral, but rather a single integral. Now let's look at an example. Example such as this. Integral x squared dx all over square root of 9 minus x squared, 9 minus x squared. You see, when you look at this carefully, this one, it takes the form of this. Because this one can be written as this. This one solution is the same as x squared dx over square root of 3 squared minus x squared. So that a squared is 3 squared, u squared is x squared, And when it was like, they said, A square, we said, U equals A sine theta. Our A is what? 3. Our U here is X. So, we can conveniently say that let X is equal to 3 sine theta. Let X is equal to 3 sine theta. Now, if X is equal to 3 sine theta, then we continue our integration to be this one will be equation 1. If this is equation 1, then whenever we see X, we put there 3 sine theta. Whenever you see X, we put there 3 sine theta. Insofar as X is equal to sine theta is going to dominate. Here sine theta squared, sine theta squared. Then the X needs to be changed. The X needs to be changed. If the X needs to be changed, then you have to integrate X is equal to 3 sine theta. If you have to differentiate this so that we shall get the X expressed in terms of theta. So if you differentiate X, it gives you 1, and that will give us the X is equal to this will give us 3 cos theta d theta. So that whatever we can see that the X has been expressed in terms of theta. The X is equal to 3 cos theta d theta. So whenever you see the X here, we put there 3 cos theta d theta because the X is equal to that. It is clear. Now, we do substitution. This will give integral x squared 3 sine theta squared times dx, which is 3 cos theta d theta. All divided by square root of 3, 9 minus s squared, which is 3 sine theta squared. The top will give me integral. The top I will get integral 9 sine squared theta times 3 cos theta d theta all over square root of. This is 9. 3 sine theta squared will give us 9 minus 9 sine squared theta. So I can continue with it here. Now look at this. Look at something here. Let me express this one. This one. 9 minus 9 sine squared theta. You see that it's under root sign. But that one I can factorize 9 out to be 1 minus sine squared theta. You see that? You see that it is under the square root sign. I'm talking about this one. So that this one is the same as this. And I can factorize if you have root A times B is the same as root A times root B. So this is the same as root 9 times root 1 minus sine squared theta. Root 9 will give me 3 and root 1 minus sine squared theta. And 1 minus sine squared theta is cos squared theta. So the whole of this one will give me 3 root 1 minus sine squared theta here. Factorizing 9 out, factorizing root 9 out. Then you get root 1 minus sine squared theta. So that this one will give me integral. Therefore, you see there's 9 here. 9. Then 9 can come outside here. It will be 9 integral sine squared theta times 3 cos theta all over 3 square root of. I've said if you factorize 9 out, you will get 1 minus, if you factorize root 9 out, you will get 1 minus sine squared theta. Root 9 out, which root 9 will give 3. 1 minus sine squared theta. And 1 minus sine squared theta in trigonometry. 1 1 minus sine square theta is the same as cos square theta, because sine square theta plus cos square theta is equal to 1. So you get cos square theta. Now this will give me 9 integral sine square theta times 3 cos theta, all divided by, if you take square root of cos square theta, square root of cos square theta will give you cos theta times 3, will give us 3 cos theta. So that this 3 cos theta will cancel this 3 cos theta. And we shall have 9 integral sine square theta. In fact, there is the theta there. The theta. Now, this one too, unless it is expressed, sine square theta can be expressed in terms of sine square theta is equal to 1 over 2, 1 minus cos 2 theta. Sine square theta can be expressed in this way. That is trig identity. This one is trigonometric identity. So in this way, it's not very easy to integrate. Sine square theta is equal to 1 over half 1 minus cos 2 theta. The reason why you should know that is that if you have cos 2 theta, it's the same as cos square theta minus sine square theta. So that the cos 2 theta will be equal to cos square theta. Cos 2 theta is equal to this. If you change this cos square theta, what is the same as 1 minus sine square theta, then this one to minus sine square theta. You should have get cos 2 theta is equal to 1 minus sine square theta minus sine square theta will be 2 sine square theta. So that if you want sine square theta, this one is negative. It will be here 2 sine square theta is equal to 1 minus, this one will cross cos 2 theta. Then you divide both by 2. By 2. This one cancels. So that you get sine square theta is equal to 1 minus cos 2 theta divided by half. Divided by 2, which is the same as half 1 minus cos 2 theta. This one you should not forget. This one is trigonometry. Follow my videos on trigonometry, you understand this. So I will just fix sine square theta with this. So that this one will give me 9 integral 1 over 2 1 minus cos 2 theta d theta. So that this one, I'll factorize this one, this half out to be 9 over 2 integral 1 minus cos 2 theta d theta. Now I'm going to integrate the inside. Integrating this will give me 9 over 2. If I integrate 1, because it is d theta, it will give me theta minus. If I integrate cos theta, it will give me sine. Cos 2 theta will give me sine 2 theta here over 2 plus c. If you differentiate this, you get, if you differentiate sine theta, if you differentiate sine theta, you get cos theta. But it will be, if you differentiate this, it will be 2 sine 2 theta, and these two will cancel that. You get back. You get back the same thing. So 9 over 2 theta minus 9 over 4 sine 2 theta plus c. But interestingly, you see that you can find theta. You can find theta. You see here you have x is equal to 3 sine theta. Let me write it here. X is equal to 3 sine theta from this. You can find theta and substitute here. Because if you have this, you can divide both sides by 3. This one can you have sine theta is equal to x over 3. So that you write theta is equal to sine inverse of x over 3. So this is what I write here. Theta is equal to sine inverse of x over 3. So I will get 9 over 2 sine inverse of x over 3 minus 9 over 4 sine 2 theta plus c. And this is the integration of this integration of the function s squared all over square root of 9 minus s squared dx. So this is how to integrate this. You employ this technique of the u all over a squared minus u squared. Now what about if it is of this nature or this nature? Let's see how to go by. Okay, let's have a look at an example like dx all over 4x squared plus 4x plus 2. Let's see how this goes. This follows some of the techniques I've explained. If you have this, you pick the denominator, complete the squares. So 4x squared plus 4x plus 2. Factorize 4 out, you get 4. X squared plus x plus 1 over 2. But I'm dividing each term by 4. So if you divide 4 over 2, 2 over 4 gives us half. 4 out. Half the equation of x. Equation of x is 1. So give us half of 1 give us half. So give us x plus half squared. You see that if you expand this, you get x squared plus x plus 1 over 4. There is no 1 over 4 here. So I will subtract minus 1 over 4. So that this 1 over 4, negative 1 over 4, will neutralize the positive 1 over 4 that will be born out of the expansion of x plus half squared. Then plus this half. So we shall have 4 multiplying x plus half squared plus, because 1 over 4, negative 1 over 4 plus half will give us 1 over 4. Negative half, negative 1 over 4 plus half will give us positive 1 over 4. So the whole of this I can be written as integral dx all over 4 out x plus half squared plus 1 over 2 squared. 1 over 2 squared is 1 over 4. If you 1 over 2 squared is the same as 1 over 4. Now I can factor 1 over 4 out to be 1 over 4 integral dx over x plus half squared plus 1 over 2 squared. So if you look at this looks similar to those that we have solved before. Because I said if you have integral dx over a squared plus u squared or u squared plus a squared, the appropriate substitution is u is equal to a tan theta. U is equal to a tan theta. You see that? So our a is half, our u is x plus 2, x plus half. This is the type of technique I was explaining in the very first time I started the introduction into different techniques of solving integration. So here I'll get 1 over 4 integral. Let x plus half is equal to half tan theta. Half tan theta. So whenever I see x plus 1 over 4, put there half tan theta. Now, because I've written tan theta to replace x plus half, then I have to express the x in terms of tan theta. The relationship between x and tan theta will manifest clearly when you differentiate this. Let this one be my equation 1. When you differentiate from this one, this half is a constant, give 0. Dx will give us 1 dx. What is dx? Dx is equal to half sec squared theta d theta. You see that now dx has been clearly expressed in terms of theta. So that we shall have, let us do the substitution. We have 1 over 4 integral dx, which is half sec squared theta d theta over x plus half is half tan theta. But x plus half is squared. So half tan theta squared plus 1 over 4. Half squared is 1 over 4. This one will give me 1 over 4 integral half sec squared theta d theta all over. This will give me 1 over 4 tan squared theta plus 1 over 4. Now, you see that 1 over 4 integral half sec squared theta d theta over. I will factorize 1 over 4 because 1 over 4, 1 over 4 is here. 1 over 4 here outside tan squared theta plus 1. You see that half, we have 1 over 4, half divided by 1 over 4 give me 2. 2 sec squared theta d theta. All divided by tan squared theta plus 1 will give us sec squared theta. Sec squared theta. So that these two will even take these two. So we shall have half integral sec squared theta will cancel sec squared theta because these two takes this one give us half. Will give us the theta. Now integrate. If you integrate the theta, it will give you theta. Because it's like having integral dx. It means that it is 1 dx. If you integrate 1, you get x. So since it is the theta, you are integrating with respect to theta. If it is dx, you are integrating with respect to x. So here is 1 d theta. So this will give me half theta plus c. This is what you get when you integrate this. But the fact that theta can be calculated from x plus half is equal to half tan theta. So if you have half x plus half is equal to half tan theta. What do you do? Multiply each side by 2. So I will multiply 2 by x plus half is equal to half tan theta by 2. So this one will take off this. So that we get tan theta is equal to 2 times x will give us 2x. 2 times half will give us 1. So that in effect we get tan theta is equal to, let me bring it here. You see that this one will get tan theta is equal to, this cancels it. 2 times x, 2x. 2 times half will give us 1. So we get 2x plus 1. So if you have this, you can clearly write, if you have tan theta is equal to 2x plus 1, and you want theta. Theta is equal to tan inverse of 2x plus 1. So that I substitute here. Because when I integrated, I have half theta plus c. And theta is tan inverse of 2x plus 1. So I'll get half tan inverse of 2x plus 1 plus c. And that is my answer. May God bless you. Follow me on YouTube for more videos. Follow me on YouTube for more videos. Ninja Easy Mathematics. Thank you very much. May God bless you.
Thank you.